The universe as we know it operates on a set of rules, a cosmic code of conduct. These rules, often referred to as the laws of physics, govern everything from the tiniest particles to the largest galaxies. They are the invisible threads that weave the fabric of our reality, ensuring that the universe remains a coherent and predictable place. From the moment of the Big Bang, these laws have been in place, guiding the formation of stars, planets, and galaxies, and ultimately the emergence of life itself. They are the reason why apples fall from trees, why the Earth orbits the sun, and why light travels at a constant speed. Without these laws, the universe would be a chaotic and unpredictable place, where anything could happen at any moment. But what exactly are these laws, and how do they shape our understanding of the cosmos? Gravity, that invisible force, pulls objects together, dictating the dance of planets around stars. It is the force that keeps our feet firmly planted on the ground and holds the moon in its orbit around the Earth. Gravity is one of the four fundamental forces of nature, along with electromagnetism, the strong nuclear force, and the weak nuclear force. It is the weakest of these forces, but it has the most far-reaching effects, shaping the structure of the universe on the largest scales. Without gravity, there would be no stars, no planets, and no galaxies. The universe would be a dark and empty void, devoid of the structures that make it so fascinating and beautiful. But gravity is not just a force that acts on large scales. It also plays a crucial role in the behavior of objects on smaller scales, from the motion of planets and moons to the formation of galaxies and clusters of galaxies. It is a force that we experience every day, but its true nature remains one of the greatest mysteries of modern science. Light, at its constant speed, paints our world with colors, a messenger from distant corners of the cosmos. It is the fastest thing in the universe, traveling at a speed of 299,792,458 meters per second. Light is a form of electromagnetic radiation which also includes radio waves, microwaves, infrared radiation, ultraviolet radiation, X-rays, and gamma rays. These different forms of electromagnetic radiation are all part of the same spectrum, but they have different wavelengths and frequencies. Light is unique in that it can travel through the vacuum of space, allowing us to see distant stars and galaxies. It is the primary way that we receive information about the universe beyond our own planet. When we look up at the night sky, we are seeing light that has traveled for millions or even billions of years to reach us. This light carries with it information about the objects that emitted it, allowing us to study the properties of stars, galaxies, and other celestial bodies. But light is not just a passive messenger. It also plays an active role in shaping the universe, from the formation of stars and planets to the behavior of atoms and molecules. And then there are atoms, the building blocks of everything we see and touch, behaving with predictable precision. Atoms are made up of a nucleus of protons and neutrons, surrounded by a cloud of electrons. The behavior of these particles is governed by the laws of quantum mechanics, which describe the strange and often counterintuitive behavior of matter on the smallest scales. Atoms combine to form molecules, which in turn combine to form the substances that make up the world around us. The properties of these substances are determined by the arrangement and interactions of their atoms and molecules. For example, the hardness of a diamond, the flexibility of a rubber band, and the taste of a piece of chocolate are all determined by the behavior of the atoms and molecules that make them up. The study of atoms and molecules is the foundation of chemistry, which seeks to understand the properties and behavior of matter at the atomic and molecular level. But atoms are not just the building blocks of matter, they are also the source of the energy that powers the stars and fuels the processes of life. These constants, these unwavering laws of physics, are the bedrock of our reality. They are the principles that allow us to make sense of the world around us, to predict the behavior of objects and systems, and to develop technologies that improve our lives. The laws of physics are expressed in the form of mathematical equations, which describe the relationships between different physical quantities. These equations are based on a set of fundamental constants, such as the speed of light, the gravitational constant, and the Planck constant. These constants are the same throughout the universe, and they provide a framework for understanding the behavior of matter and energy on all scales. The study of these laws and constants is the foundation of physics, which seeks to understand the fundamental principles that govern the behavior of the universe. But the laws of physics are not just abstract concepts. They have practical applications in a wide range of fields, from engineering and medicine to astronomy and cosmology. They are the stage upon which the grand cosmic drama unfolds. The universe is a vast and dynamic place, filled with a rich tapestry of structures and phenomena. From the birth and death of stars to the formation of galaxies and the expansion of the universe itself, the laws of physics provide the framework for understanding these processes. The study of the universe, known as cosmology, seeks to understand the origin, evolution, and ultimate fate of the cosmos. It is a field that combines observations of the night sky with theoretical models and simulations to explore the fundamental questions of existence. How did the universe begin? What is it made of? How will it end? These are some of the questions that cosmologists seek to answer. But the universe is not just a subject of scientific inquiry. It is also a source of wonder and inspiration, a reminder of the beauty and complexity of the natural world. But what if, and this is where our minds must venture into the realm of pure imagination, what if these laws weren't so constant? What if the fundamental principles that govern the behavior of the universe were subject to change? This is a question that challenges our understanding of reality and forces us to think outside the box. It is a question that has been explored in science fiction and speculative fiction, where authors imagine worlds with different physical laws and explore the implications of these changes. But it is also a question that has been considered by scientists and philosophers who seek to understand the nature of the laws of physics and their role in shaping the universe. What would happen if the speed of light were different? If gravity were stronger or weaker? If the fundamental constants of nature were not constant at all? These are questions that push the boundaries of our knowledge and challenge us to think in new and creative ways. What if, like the shifting sands of time, they changed, morphed, and rearranged themselves every single day? Imagine a world where the laws of physics were in a constant state of flux, where the behavior of matter and energy was unpredictable and ever-changing. In such a world, the familiar patterns and structures of the universe would be replaced by a chaotic and dynamic landscape, where anything could happen at any moment. The stability and predictability that we take for granted would be replaced by uncertainty and randomness. The very fabric of reality would be in a constant state of transformation, with new rules and principles emerging and disappearing on a daily basis. This is a world that defies our understanding of physics and challenges our perception of reality. It is a world that forces us to reconsider the nature of the universe and our place within it. Imagine waking up every morning to a world subtly, or perhaps dramatically, different from the one you left behind the night before. In such a world, the familiar landmarks and structures of our environment would be constantly changing, with new landscapes and features emerging and disappearing on a daily basis. The laws of physics that govern the behavior of matter and energy would be in a constant state of flux, leading to unpredictable and often bizarre phenomena. The stability and predictability that we take for granted would be replaced by uncertainty and randomness. The very fabric of reality would be in a constant state of transformation, with new rules and principles emerging and disappearing on a daily basis. This is a world that defies our understanding of physics and challenges our perception of reality. It is a world that forces us to reconsider the nature of the universe and our place within it, a world where the familiar laws of physics are but a distant memory, replaced by a new set of rules, a new reality. In such a world, the behavior of matter and energy would be governed by principles that are completely different from those we know. The fundamental constants of nature would be different, leading to new and unfamiliar phenomena. The structures and patterns that we take for granted would be replaced by new and unpredictable forms. The stability and predictability that we take for granted would be replaced by uncertainty and randomness. The very fabric of reality would be in a constant state of transformation, with new rules and principles emerging and disappearing on a daily basis. This is a world that defies our understanding of physics and challenges our perception of reality. It is a world that forces us to reconsider the nature of the universe and our place within it. Could we, humanity, accustomed to a certain cosmic order, survive in such a chaotic universe? Our entire existence is based on the stability and predictability of the laws of physics. From the functioning of our bodies to the technologies that we rely on, everything is based on the assumption that the laws of physics are constant and unchanging. In a world where these laws were in a constant state of flux, our very survival would be in question. We would be forced to adapt to new and unpredictable conditions, to find new ways of understanding and interacting with the world around us. The stability and predictability that we take for granted would be replaced by uncertainty and randomness. The very fabric of reality would be in a constant state of transformation, with new rules and principles emerging and disappearing on a daily basis. This is a world that defies our understanding of physics and challenges our perception of reality. It is a world that forces us to reconsider the nature of the universe and our place within it. Join me now as we embark on a thrilling and perhaps slightly unnerving thought experiment. Let us imagine a world where the laws of physics are not constant, but are in a constant state of flux. Let us explore the implications of such a world, and consider how it would affect our understanding of the universe and our place within it. This is a journey into the unknown, a journey that challenges our understanding of reality and forces us to think in new and creative ways. It is a journey that takes us to the very edge of our knowledge and beyond. So let us set aside our preconceptions and open our minds to the possibilities. Let us embark on this journey together and see where it takes us. Let's explore a world where the laws of physics are as predictable as the weather, as fickle as fate itself. In such a world, the behavior of matter and energy would be in a constant state of flux, leading to unpredictable and often bizarre phenomena. The stability and predictability that we take for granted would be replaced by uncertainty and randomness. The very fabric of reality would be in a constant state of transformation, with new rules and principles emerging and disappearing on a daily basis. This is a world that defies our understanding of physics and challenges our perception of reality. It is a world that forces us to reconsider the nature of the universe and our place within it. Let's ask the question, what if the laws of physics changed every day? What would such a world look like? How would it affect our understanding of the universe and our place within it? These are questions that challenge our understanding of reality and force us to think in new and creative ways. They are questions that take us to the very edge of our knowledge and beyond. So let us set aside our preconceptions and open our minds to the possibilities. Let us embark on this journey together and see where it takes us. For centuries, we've looked up at the stars, marveling at their beauty and wondering about the mysteries they hold. The night sky has always been a source of inspiration and curiosity for humanity. Ancient civilizations used the stars for navigation, to mark the passage of time and to tell stories about their gods and heroes. The stars have been our companions, guiding us through the ages and sparking our imagination, and down at the world around us, seeking to decipher the intricate workings of the universe. From the smallest particles to the vast expanse of space, we've always been driven by a desire to understand how everything fits together. We've observed the patterns in nature, the cycles of the seasons, the behavior of animals, and the growth of plants. We've studied the elements, the weather, and the forces that shape our planet. Our quest for knowledge has taken us from the depths of the oceans to the highest mountains, and even beyond our own atmosphere. From the ancient Greeks to the modern physicists, the quest to understand the fundamental laws governing our reality has been a constant. The Greeks pondered the nature of matter, the structure of the cosmos, and the principles of motion. They laid the groundwork for the scientific method, emphasizing observation, experimentation, and logical reasoning. Over the centuries, scientists have built upon this foundation, making groundbreaking discoveries and developing new theories. The Renaissance brought a renewed interest in science, leading to the birth of modern physics. The Enlightenment further advanced our understanding of the natural world, with scientists like Newton and Galileo making significant contributions. And, for the most part, we've done a pretty good job. We've made incredible strides in our understanding of the universe, uncovering the secrets of the stars, the planets, and the forces that govern them. We've developed technologies that allow us to explore space, communicate across vast distances, and harness the power of the atom. We've mapped the human genome, discovered new elements, and created materials with extraordinary properties. Our achievements in science and technology have transformed our world, improving our quality of life and expanding our horizons. We've identified the forces that hold the cosmos together, the fundamental interactions that govern the behavior of matter and energy. These forces include gravity, which pulls objects toward each other, electromagnetism, which governs the behavior of charged particles, and the strong and weak nuclear forces, which hold atomic nuclei together and govern radioactive decay. These forces are responsible for the structure and dynamics of the universe. from the formation of galaxies to the behavior of subatomic particles, the delicate balance of gravity, electromagnetism, the strong and weak nuclear forces. Each of these forces plays a crucial role in the stability and behavior of the universe. Gravity, for example, is responsible for the formation of stars and planets, as well as the orbits of celestial bodies. Electromagnetism governs the behavior of light, electricity, and magnetism, and is responsible for the interactions between atoms and molecules. The strong nuclear force holds atomic nuclei together, while the weak nuclear force is responsible for certain types of radioactive decay. Together, these forces create the complex and dynamic universe we observe. We've measured the speed of light, that cosmic speed limit, which is approximately 299,792 kilometers per second. This constant is fundamental to our understanding of the universe, as it sets the maximum speed at which information and matter can travel. The speed of light plays a crucial role in the theory of relativity, which describes the relationship between space and time. It also affects our observations of distant objects, as the light we see from stars and galaxies has traveled vast distances to reach us, providing a glimpse into the past, and we've peered deep into the heart of matter, unraveling the mysteries of atoms and their constituents. We've discovered that atoms are made up of a nucleus, containing protons and neutrons, surrounded by a cloud of electrons. We've identified the fundamental particles that make up protons and neutrons, known as quarks, and the particles that mediate the fundamental forces such as photons and gluons. We've built powerful particle accelerators to study these particles and their interactions, revealing the underlying structure of matter and the forces that govern it. These laws, these constants, have held true, unwavering for as long as we've been able to observe them. The laws of physics, such as the conservation of energy and momentum, the principles of thermodynamics and the equations of motion, have provided a consistent framework for understanding the natural world. These constants, such as the speed of light, the gravitational constant, and the charge of the electron, have remained stable and predictable, allowing us to make accurate predictions and develop advanced technologies. But what if our perception of these laws as immutable, as eternal, is flawed? What if the constants we rely on are not as fixed as we believe? Some scientists have begun to question the stability of these laws, suggesting that they may change over time or vary in different regions of the universe. This idea challenges our fundamental understanding of reality and raises profound questions about the nature of the cosmos. What if the very fabric of reality, the laws that govern it, are not as fixed as we believe them to be? If the laws of physics can change, what does that mean for our understanding of the universe? Could there be regions of space where the laws are different, or times in the past or future when the constants have changed? These questions push the boundaries of our knowledge and challenge us to rethink our assumptions about the nature of reality. Could it be that the universe, in its infinite vastness and complexity, has a few surprises up its sleeve? The idea that the laws of physics might not be constant opens up a realm of possibilities, from the existence of parallel universes with different physical laws, to the potential for new forms of matter and energy. It suggests that our understanding of the universe is still incomplete, and that there may be fundamental aspects of reality that we have yet to discover. This may seem like the stuff of science fiction, but some physicists theorize that the laws of physics, those very constants we hold dear, might have been different in the early universe. The conditions in the early universe were vastly different from those we observe today, with extreme temperatures and densities that could have affected the behavior of matter and energy. Some theories suggest that the constants of nature, such as the strength of the fundamental forces, may have evolved over time, leading to the universe we see today. Could they be different in other parts of the cosmos, in realms beyond our current reach? The universe is vast and there are regions of space that we have yet to explore. It's possible that the laws of physics vary in different parts of the cosmos, leading to different physical phenomena and structures. This idea challenges our understanding of the universe as a uniform and consistent entity, and suggests that there may be hidden realms with their own unique properties. And if so, what does that mean for our understanding of reality itself? If the laws of physics are not constant, it could have profound implications for our understanding of the universe and our place within it. It could change the way we think about space, time, and matter, and open up new avenues of research and exploration. It challenges us to question our assumptions and to seek a deeper understanding of the nature of reality. The quest to understand the universe is far from over, and the mysteries of the cosmos continue to inspire and challenge us. Imagine waking up one morning to a world subtly yet profoundly different. The familiar sounds of your alarm clock ring through the room, but as you open your eyes, you sense an unusual stillness in the air. The light filtering through your window seems to dance in a way you've never seen before, casting strange, elongated shadows across your room. You sit up, rubbing your eyes, trying to shake off the remnants of sleep, but the feeling persists. Something is undeniably different. The sun rises, painting the sky with familiar hues, but something feels amiss. The colors are more vibrant, almost too vibrant, as if the sky itself is trying to tell you something. The usual morning chorus of birds is absent, replaced by an eerie silence that sends a shiver down your spine. You can't quite put your finger on it, but the world outside your window seems to be holding its breath, waiting for something to happen. As you swing your legs out of bed, you notice a distinct lack of resistance, a peculiar lightness. It's as if the very air around you has lost some of its weight, making every movement feel strangely effortless. You stand up, expecting the usual creak of the floorboards beneath your feet, but instead, you feel as though you're walking on a cloud. The sensation is both exhilarating and disconcerting, leaving you with a sense of unease that you can't quite shake. You push off the ground, expecting the familiar pull of gravity, but instead, you find yourself drifting towards the ceiling. Panic sets in as you flail your arms, trying to grasp onto something solid, but there's nothing to hold on to. The room spins around you, and for a moment you feel completely untethered, like a balloon that slipped from a child's grasp. Just as quickly as it began, the sensation subsides, and you find yourself gently floating back down to the floor, your heart pounding in your chest. The day has begun, and gravity, that invisible force that governs so much of our lives, has decided to take a well-deserved break. You make your way to the kitchen, hoping a cup of coffee will help clear your mind, but as you reach for the pot, you notice it floating gently above the counter. Objects that were once firmly grounded now drift lazily through the air, as if they too have been freed from the constraints of gravity. You watch in awe as your coffee cup hovers in front of you, the liquid inside forming perfect weightless spheres that float serenely in the air. Or at least, it has weakened significantly, reduced to a mere whisper of its former self. The furniture in your living room floats a few inches off the ground, swaying gently like leaves in a breeze. You push off the floor and find yourself gliding effortlessly through the air, the sensation both thrilling and surreal. It's as if the entire world has been transformed into a dreamscape, where the rules of physics no longer apply. Your morning commute takes on a whole new meaning. You step outside, half expecting to see the familiar sight of cars lined up along the street, but instead, you find them floating several feet above the ground, bobbing gently like balloons. The usual hustle and bustle of the morning rush hour is replaced by a strange, almost serene calm, as people navigate this new, gravity-defying world with a mixture of wonder and trepidation. Cars, no longer bound by gravity's grip, bob and weave through the air like wayward balloons. Drivers, now more like pilots, carefully maneuver their vehicles through the sky, avoiding collisions with the same skill and precision they once used on the ground. The streets below, once teeming with life, are now eerily empty, their purpose rendered obsolete in this new, floating reality. Traffic lights dangle precariously, their purpose rendered moot as vehicles navigate a three-dimensional obstacle course. The familiar red, yellow, and green lights swing gently in the breeze, their once authoritative commands now little more than colorful decorations in a world where up and down have lost their meaning. Drivers rely on instinct and quick reflexes to avoid collisions, weaving through the air with a grace and agility that would have been unimaginable just a day before. The roads themselves, stripped of their usual function, begin to crack and buckle under the strain of a world suddenly devoid of its usual downward pull. Pavement that was once solid and unyielding now shifts and warps, unable to withstand the new forces at play. Debris floats lazily above the ground, creating an otherworldly landscape that feels more like a scene from a science fiction movie than the familiar streets of your hometown. But it's not just the man-made world that's in disarray. The natural world, too, has been thrown into chaos by the sudden weakening of gravity. Trees that once stood tall and proud now sway violently, their roots struggling to anchor them to the ground. The once stable earth beneath your feet feels uncertain and unpredictable, as if it could give way at any moment. trees sway violently, their roots struggling to anchor them to the ground. The once sturdy trunks bend and twist, their branches reaching out in all directions as if trying to grasp onto something solid. Leaves flutter through the air, carried away by the slightest breeze, creating a swirling, chaotic dance that mirrors the turmoil of the world around you. Rivers and lakes, no longer confined to their basins, rise into the sky, forming shimmering ethereal sculptures of water droplets. The water, freed from the pull of gravity, takes on a life of its own, creating intricate patterns and shapes that defy explanation. You watch in awe as a stream of water rises from a nearby lake, twisting and turning in midair before dispersing into a fine mist that sparkles in the sunlight. The very air feels different, thinner, as if the atmosphere itself is struggling to maintain its grip on the planet. The sky above is filled with unusual patterns and floating particles, creating a surreal, almost dreamlike landscape. The familiar blue has taken on a strange, otherworldly hue, and the clouds seem to hang in the air, suspended in time. As you take a deep breath, you can feel the difference in the air, a subtle reminder that the world you once knew has changed in ways you can barely comprehend. Light, it bathes our world, illuminating the planets, stars, and galaxies that make up our universe. It's the fastest thing we know of, traveling at a staggering 299,792,458 meters per second. This speed isn't just a number, it's a fundamental constant, woven into the very fabric of the cosmos. Think of it this way: the speed of light dictates how we experience time, how far we can see into the cosmos, and even how energy travels through space. It's the ultimate speed limit, a cosmic rule that governs everything from the smallest atoms to the largest black holes. But now, imagine a world where this fundamental constant, this cosmic speed limit, is broken. Imagine a day when the speed of light plummets, slowing down to a mere 1 meter per second. What would happen to our world, to our perception of reality, if light itself were to crawl at a snail's pace? Atoms. Tiny, invisible particles, far too small to be seen with the naked eye. Yet these minuscule entities are the fundamental building blocks of everything we know, everything we see, everything we are. They are the bricks and mortar of reality, the very essence of existence. The way atoms interact, the forces that bind them together, determines the properties of matter. It dictates whether a substance is solid or liquid, gas or plasma. It governs the colors we see, the textures we feel, the very air we breathe. We humans, we're a resourceful bunch. We've built skyscrapers to touch the clouds, machines that can think, and even ventured beyond the confines of our own planet. But all of our achievements, every marvel of engineering and technology, rely on one crucial assumption: that the laws of physics are constant, unwavering, the very bedrock of reality. But just imagine, a world where this wasn't the case. A world where the rules of the game could change without warning, where gravity might be a suggestion rather than a law. Could we, with all our ingenuity, adapt to such a volatile existence? Could we design buildings that could adjust their weight distribution on the fly, morphing and shifting to counteract a sudden decrease in gravity? Imagine clothing that could become buoyant if gravity decided to take a day off, or vehicles that could seamlessly transition from asphalt to air travel. The challenges would be immense, requiring a level of technological sophistication that dwarfs even our most ambitious dreams. It would be a world where the line between science fiction and reality blurs, where every sunrise could bring about a new set of physical laws to decipher, but perhaps, just perhaps, necessity would become the mother of invention on a scale never before imagined. We tend to think of the universe as a well-oiled machine governed by a set of immutable laws that have been in place since the dawn of time. Gravity, electromagnetism, the strong and weak nuclear forces, these fundamental forces shape the cosmos, dictating the interactions of every atom, star, and galaxy. But what if this perception of stability is merely an illusion, a product of our limited human perspective? What if, on a timescale far grander than we can fathom, these fundamental forces are not so constant after all? Imagine a universe where the strength of gravity ebbs and flows, where the speed of light fluctuates like the tides, and the very fabric of space-time stretches and contracts like a cosmic lung. Could it be that our current understanding of physics is merely a snapshot, a single frame in a cosmic movie that has been playing for billions of years? Are we simply blind to the larger, more dynamic picture, like ants crawling on a twig, oblivious to the fact that they are part of a vast and ever-changing forest? We've journeyed from the familiar pull of gravity to the very edges of our understanding of the universe. We've explored the unsettling possibility of a reality where the laws of physics are not constant, but fluid, ever-changing, and perhaps even unpredictable. What do you think? Could you adapt to a world where the ground beneath your feet could shift at any moment, where the very nature of reality is in constant flux? Would you embrace the chaos, the endless possibilities, the challenge to our understanding of the universe? Let us know in the comments below. And don't forget to subscribe for more mind-bending explorations of the universe and beyond right here on What If?